Assalamualaikum and a very good morning. So for today, our group is group 5. We present to you our project. It is by Sequential LED Indicator. So our group member is Muhammad AKASHAH bin SHAMSHUDDIN with matrix number 207271. Muhammad HASIF bin MAHAZIR with matrix number 206444. And myself is NURSYAIDA FARHANAH binti NORLI with matrix number 206429. So for the introduction, I will present to you. This project title is Byte Sequential LED Indicator. The aim of this project is to build and implement a byte sequential LED indicator circuit using a 555 timer. While bike riding is solidarity practice that offers a sense of contentment to people who just love to feel the road, it becomes important that you can communicate clearly with other vehicles too. This like that permit vehicle operators to notify other drivers of their intention with respect to the vehicles. An indicator light is mainly used on the circuit or mechanical equipment to monitor and alarm the operation status of the equipment. These lights are therefore critically important in preventing accident and corresponding injuries. Yellow light may be used where the particular color emitted is selected by the operating function. As we know, LED stands for light emitting diode, and LED is an electronic device that emits lights when an electrical current is passed through it. With 4 LEDs glowing one by one in a particular pattern, and we can control the speed of frequency of this LED indicator by simply turning a potentiometer. The power flows through the filament of the light and then is ground. That's all for introduction. Thank you.
Assalamualaikum and good day to everyone. My name is Muhammad AKASHAH bin SHAMSHUDDIN and my metric number is 207 and 201. So I will be the next presenter to explain about the theory of our project. So as you can see here, which is about our project implementation, which is in another word, is our initial design, which will be implemented into the multisim to further our experimentation of the value itself. And the next one, which is about the theory. So in the theories that we use in the project, for the whole project, is the first one, which is the Ohm's law. So it states that the voltage through an element is equal to that of the element current times the current flowing through the element, which is in another word, which is V equals to IR. And the second one, which is the Kirchhoff current law. It states that the current flowing into the node or a junction must be equal to the current flowing out of it. And the third one, which is the current voltage law, which states that in any complete loop within a circuit, the sum of all the voltage across components which supply electrical energy, such as cells or generators, must equal to the sum of all the voltage across the other component in the same loop. The fourth one, which is 555 timer integrated circuit, integrated chip, and it is used in a variety of timer delay, which is our main operation of the whole project, and pulse generation, and also our oscillator application. The fifth one, which is diode, which is a device that allows current to flow in one direction but not the other. The transistor is a semiconductor device which is for applying, controlling, and generating electrical signals. And last but not least is bipolar transistor, or known as BJT, which is current regulating devices that control the amount of current flowing through them from the emitter to the collector terminals in proportion to the amount of biasing voltage applied to their base terminal, thus acting like a current control switch. That is all about theories. I will pass to the next presenter.
Wabarakatuh. My name is Muhammad HASIF bin MAHAZIR and my matrix number is 206444. And today we are going to discuss our project that it is byte signal. So the result of our project is this is our simulation that we use to design our circuit. So the list of component is transistor, 555 timer, and two 4700 resistor, and 5 10k resistor, and power supply LED quantity 5, and a capacitor, and 5-volt battery. So this is our video of simulation. As we can see that the LED will sequential. So the result of the 5 timer IC is it will result a pulse to on and off the LEDs. So as we can see, the LED 1, 2, 3, and the pulse that 5 timer gives, it will have some delay to on and off. So when it off, we can see that it will have the delay around here. So now I'm going to discuss about our project. So the 1N4148 diode is connected in reverse bias as at the output of the pin of 555 timer IC to maintain the constant current, and the LEDs are connected to the transistor through a 1k ohm resistor with respect to VCC. So current that flow through all the LED, that is when there's voltage through X1 LED. We are using 1k ohm resistor through the LED to prevent our LED from damage. So the voltage drop was 1.9 voltage, and current was 1.5 milliampere, and the current flows through the 10k ohm resistor of 0.43 milliampere, and the current at the emitter by using KCL method, that is IE equals to IC minus IB.
Alright, since HASIF explained a little bit about the discussions, I will furthermore about the discussion which is the calculation part here. As you can see here, first foremost, the power source is 9 volt, which is will flow toward at each of the node itself, toward passing through each of the resistor. And since the function of 555 timer is to delay, that means it will delay the current to pass through here, 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 and here. So it will go through to R6 first, which is connected in series with the ground, and then it will pass through with the delay current to the LED 4, LED 3, LED 2, and LED 1, and it will reset it again to create the sequential LED. So from here, actually the power source will passes at two directions, which is from here at the top and also from the out pin of the 555 timer, which is will flow passing the R3 and will flow here and not here. And at the end, all of the currents will collapse here and will overflow toward the ground. I think that's all from me. Thank you.
So for the conclusion of this project, we can conclude that it was found that when the input was fed into the logic gates through the output that was observed through a LED came out to be exactly the same as the desired output, and the truth table were in fact proven true. This project verifies Ohm's law, Kirchhoff's current law, and Kirchhoff's voltage law. This project also shows that the speed of LED to blinking is based on the frequency at the digital clock. For the speed LED, for each LED is determined by the 555 timer IC. For the improvement to be made for the future works, maybe the LED can work in many variations, as for example, SOS signal and many more. And for the future work also may include sound for more safety to the rider in the dark weather. So for error and precaution, for error is a wrong connecting the circuit. For the precaution is the emitter is used to measure the current. It is always connected in series with the circuit. Wrong connecting the emitter will damage the instrument. Second is timing oscillation. Precaution is ignore the first few oscillations and start timing only when the oscillations are steady. And the third one is when judging whether apparatus is horizontal or vertical. Precaution is make sure it's to simulate it nicely and simple. And the last one is hitting in the resistant wire. So for the precaution, we can switch on the circuit for a few seconds before taking a reading and then switch it off immediately. So for the reference, you can scan here. Thank you. That's all for us.